In the silent, inky blackness between stars, where the laws of physics play out on scales beyond human comprehension, something stirred. A whisper of movement, a cosmic anomaly hurtling towards our solar system at unimaginable speeds. It was a messenger, but from where? And what message did it carry? For eons, humanity has gazed at the heavens, dreaming of what lies beyond. We've charted the planets, mapped the constellations, and sent our probes to touch the edges of our cosmic neighborhood. But on October 19, 2017, the universe sent us a visitor, unlike any we had ever encountered. From the summit of Haleakala, Hawaii, the Pan-STARRS telescope, a vigilant eye on the cosmos, detected a faint, fast-moving point of light. It was an object hurtling through space, not orbiting our sun, but merely passing through. Its trajectory was unmistakable. It came from outside our solar system. It was an interstellar interloper. The initial excitement among astronomers was palpable, quickly followed by a cascade of questions. What was this object? Where did it come from? And why had it never been seen before? Initially, it was classified as a comet, given its high speed and trajectory. But as more observations poured in, a perplexing truth began to emerge. This was no ordinary comet. It lacked the telltale sign of a comet. A glowing coma, a tail of gas and dust vaporizing under the sun's warmth. It was, to all appearances, a naked rock, defying the very definition of a comet. The classification shifted. From comet, it became an asteroid, but even that felt inadequate. This object was an enigma, a cosmic anomaly that refused to fit neatly into our established categories. And then it was given a name, one that perfectly encapsulated its mysterious arrival, Oumuamua. In Hawaiian, it means a messenger from afar arriving first, a name that hinted at its profound significance, a scout from the vast unknown reaches of interstellar space, carrying secrets we were only just beginning to unravel. As astronomers scrambled to gather more data before this fleeting visitor vanished back into the cosmic void, its true form began to emerge, and what they saw defied every expectation. This wasn't a spherical rock, nor was it merely irregularly shaped. Oumuamua was extraordinarily elongated, perhaps 10 times as long as it was wide. Imagine a cosmic cigar or a flattened pancake tumbling through space. Its dimensions were estimated to be around 400 meters, a quarter mile, long yet only about 40 meters wide. This aspect ratio was unlike anything ever observed in our own solar system. Our asteroids and comets are chunky, potato-shaped. Oumuamua was a cosmic needle, a slender shard of something utterly alien. Adding to its bizarre profile was its motion. Instead of a stable, predictable spin, Oumuamua was tumbling, rotating on multiple axes simultaneously. It was like a football thrown with a wobbly spiral, or a leaf caught in a gentle breeze, gracefully yet unpredictably spinning through the vacuum. This erratic rotation further complicated efforts to understand its true nature and origin, hinting at a chaotic past, perhaps a violent ejection from its home star system. But the most perplexing revelation, the one that truly sent shockwaves through the scientific community, came as Oumuamua began its journey out of our solar system. As it sped away from the sun, it exhibited a subtle yet undeniable non-gravitational acceleration. This means it was speeding up, but not because of the sun's gravity. For comets, this acceleration is usually explained by outgassing. As the sun heats the comet, ice sublimates, creating jets of gas that act like tiny thrusters. But Oumuamua had no visible coma, no tail, no discernible signs of outgassing. It was accelerating seemingly without a cause. This was a profound violation of our understanding of how such objects behave. It was as if an invisible hand was gently pushing it along. Further analysis revealed its surface was a deep reddish-brown, a color common among objects in the outer reaches of our solar system, or those that have been exposed to cosmic radiation for vast stretches of time. Its properties suggested it was dense, composed of rock and possibly metals, completely devoid of water or ice. This dry, inert nature only deepened the mystery of its acceleration. How could something so seemingly inert be propelled without a visible engine? The questions mounted, each more profound than the last, pushing the boundaries of our scientific imagination. Oumuamua was not just an object. It was a cosmic riddle, challenging us to rethink everything we thought we knew about the universe and the silent travelers within it. Faced with an object that defied conventional explanation, scientists around the globe began to propose theories, each attempting to reconcile Oumuamua's bizarre behavior with the known laws of physics. The first line of inquiry naturally focused on natural phenomena. Could Oumuamua be a fragment of a larger celestial body, perhaps ejected from another star system during a violent planetary collision? One compelling natural explanation suggested it might be a piece of a Pluto-like exoplanet, composed primarily of nitrogen ice. This theory posited that as the nitrogen ice sublimated, it would provide the necessary thrust for the non-gravitational acceleration without producing a visible coma. Another idea proposed it was a hydrogen iceberg, a theoretical object that would also sublimate without a visible tail. These theories, while ingenious, still struggled to fully account for all of Oumuamua's peculiarities, particularly its extreme elongation and high reflectivity. But then a more radical and undeniably captivating hypothesis emerged. It came from a highly respected figure in the scientific community, Professor Avi Loeb, the former chair of Harvard University's astronomy department. Loeb, along with his colleague Shmuel Bialy, dared to ask a question that many considered taboo. What if Oumuamua wasn't natural at all? What if it was in fact an artificial object, a probe, a piece of advanced technology, or even a light sail sent by an extraterrestrial civilization? Loeb's arguments were based on the very anomalies that puzzled other scientists. He pointed to Oumuamua's extreme elongation, suggesting it was optimized for interstellar travel, minimizing drag. He highlighted the non-gravitational acceleration, arguing it was precisely what one would expect from a light sail, a vast, thin sheet propelled by the pressure of starlight, a technology we ourselves are only just beginning to explore. And its unusual brightness, far greater than expected for a typical asteroid, could be explained by a highly reflective surface designed to maximize propulsion from radiation pressure. For Loeb, the simplest explanation, given all the data, was that Oumuamua was a technosignature, a sign of technology from another civilization. This hypothesis, as you can imagine, ignited a firestorm. It was met with a mixture of fascination, excitement, and intense skepticism from the scientific establishment. Many dismissed it as sensationalism, arguing that extraordinary claims require extraordinary evidence, and that natural explanations, however convoluted, should always be exhausted first. The debate raged, not just in academic journals, but across news outlets and social media. Was this a groundbreaking new frontier in astrobiology, or a dangerous leap into unsubstantiated speculation? The Oumuamua debate became a microcosm of a larger philosophical question. How open are we as a species to the truly unexpected? How do we balance scientific rigor with the boundless possibilities of the cosmos? The messenger had arrived, and its message, whether natural or artificial, forced us to confront our place in a universe far stranger and more complex than we had ever imagined. Quickly as it arrived, Oumuamua vanished. By early 2018, it had faded beyond the reach of even our most powerful telescopes, a ghost in the cosmic machine, continuing its solitary journey into the interstellar void. We had only a few precious weeks to observe it, to gather what little data we could before it was gone forever. Its fleeting visit left us with more questions than answers, a cosmic riddle that continues to haunt the minds of scientists and dreamers alike. But Oumuamua's brief appearance had a profound impact. It confirmed what many astronomers had long suspected, that our solar system is not an isolated bubble, but rather a tiny speck in a cosmic ocean teeming with interstellar objects. If we detected one, it stands to reason that countless others are constantly traversing the galaxy, silent messengers from distant stars. This realization reshapes our understanding of planetary formation, suggesting that the ejection of material from nascent star systems is a common occurrence. It opens up new avenues of research, prompting us to consider how life might arise and travel across the vast cosmic distances. The legacy of Oumuamua is not just the mystery it presented, but the questions it forced us to ask. It has spurred new initiatives, new technologies, and new ways of thinking about our place in the universe. Future telescopes, like the Vera C. Rubin Observatory, will be even more powerful, capable of detecting fainter and faster-moving objects, increasing our chances of finding the next interstellar visitor. Perhaps, one day, we will be able to send a probe to meet one of these messengers, to study it up close, and finally unravel its secrets. Oumuamua, a fleeting visitor from the cosmic ocean. It arrived, it puzzled, and it departed, leaving behind a profound question. Are we alone? Was it a natural wanderer, a shard of a distant world, or a deliberate creation, a silent testament to intelligence beyond our own? The truth remains elusive, shrouded in the vastness of space and the limitations of our current understanding. But in its enigmatic journey, Oumuamua reminded us that the universe is far grander, far more mysterious, and infinitely more captivating than we can ever fully comprehend. And the answer, perhaps, lies in the next messenger, waiting in the silent, inky blackness between the stars, ready to whisper its secrets to those who dare to listen. The quest for knowledge continues, driven by the enduring wonder of the unknown.